Have you ever wondered how long it takes to build a modern multi-story building? You might think it takes several months or maybe even a year. You'll be surprised to hear that modern technology has advanced to the point where construction of modern multi-story buildings can be completed in just a few hours. In this video, we will tell you about the most cutting-edge construction technologies that allow homes to be built in a matter of hours and more. Enjoy watching. Let's start our compilation of incredible construction technologies with the Hadrian X robot. This unique robot is capable of laying 1,000 bricks per hour, which means it can replace a team of workers and significantly reduce construction time. The robot system consists of a large telescopic robotic arm mounted on a 25-ton truck. Electrical equipment is housed on a separate frame, and the control systems are in the van. They are all connected together and plugged into a 32-amp power source on site. Before starting its work, the robot reviews blueprints of the house, creates a 3D model, and plans its construction. The machine determines which bricks need to be cut and where these scraps can be reused, reducing waste. Then, a special adhesive is applied to the bricks, and the robot's arm places them in position, guided by a special laser. On average, Hadrian X can lay 150 bricks per hour, with a maximum speed of 200 bricks per hour, which is more than 1,500 to 2,000 bricks in a single shift, when a typical bricklayer lays around 500 bricks in the same time frame. The expression "starting to build a house from the roof" perfectly illustrates the new technique used by LiftBuild in constructing buildings. LiftBuild's technology has revolutionized the construction of skyscrapers, allowing them to be built top-down. This innovative construction method involves assembling the floors, elevating them above the ground, and lifting them on the planned platform. It presents a potential alternative to the traditional and labor-intensive process of extending steel frames, floors, walls, and all components vertically. But how does it work in practice? The answer to this question can be found in Exchange, a multi-story building that stands 63 meters tall in the Greektown area of Detroit. This 16-story project presented significant complexity due to its triangular shape, which bordered numerous city streets on all sides. The above-ground people mover system in Detroit, located adjacent to the construction site, also had a unique set of constraints. However, LiftBuild's technology allowed these challenges to be overcome and the building to be constructed. Among the advantages of this new modular construction method are simplification, standardization, and consequently, increased process efficiency and potential savings in time and budget. At the same time, it provides a safer and more productive work environment, as it eliminates work at heights and the need for tower cranes and additional equipment. Thus, the likelihood of falls, the primary cause of serious or fatal accidents in the construction industry, is reduced. It is sufficient to quote the words of LiftBuild's CEO, Joe Benvenuto: "The implementation of our proprietary methods has now been proven to produce the advantages we were anticipating, and we are confident that the results achieved at the Exchange building will set the stage for a broader commercialization of LiftBuild." Chinese never cease to amaze the world. This time, the Chinese company Broad Group has developed a building assembly technology that provides unparalleled construction speeds. It took just 28 hours and 45 minutes to create a 10-story residential building using the prefabricated components of the living building. The core elements of this new system are factory-made modules built around a stainless steel frame. All typical components of a living space, including insulation, electrical wiring, plumbing, glazing, ventilation system, and finishing, are fixed onto this frame. For the flooring, Broad Group uses their developed B-Core slabs. These slabs consist of two steel sheets interconnected with numerous short vertical tubes across the entire surface. According to the company, this solution is 10 times lighter and 100 times stronger than traditional constructions. An important advantage of the living building is that its individual components are sized to fit standard cargo containers. Thanks to this, the prefabricated blocks can be conveniently transported to almost any location worldwide using existing transportation methods. Broad Group claims that the system allows for earthquake-resistant, energy-efficient buildings suitable for various purposes, including residential homes, hotels, and hospitals. When needed, these structures can be disassembled for relocation to another site. The company states that the living building approach is suitable for constructing skyscrapers with a maximum of 200 floors. The price of individual modules is not disclosed, but it is known that a 20-apartment multi-story building by Broad Group, covering a total area of 2,948 square meters, costs less than $3 million excluding delivery costs. Isolated concrete forms are increasingly being used in house construction. This innovative material consists of expanded polystyrene foam and reinforced concrete. Until recently, it was primarily used for foundation construction. However, many companies now use this technology to build 1, 2, or 3-story walls in houses. Representatives of ICF Specialist Company use Fox blocks in their work. The unique feature of this material is that it is 10 times stronger than wood and has 2 layers of thermal insulation. This allows for up to 75% energy savings on heating the house. Thanks to Fox blocks, it is possible to quickly construct an energy-efficient and durable building in any location with minimal time investment. The company built a 205 square meter house in just one day with a team of only 13 people, which is an astonishing achievement as constructing wooden houses can take several months. ICF Blocks enables the construction of a reliable structure in a matter of days with a minimal workforce. Technologies are rapidly advancing in all areas of construction. The Dutch company Vancubavi has developed a unique machine called Tigerstone for laying stone on roads with cobblestone pavement. Compared to the traditional manual method of laying pavement, the new Tigerstone machine works 3 times faster. Tigerstone is equipped with rubber metal tracks that are powered by an electric motor. However, the laying process is not entirely automated. Loading the bricks from the hopper into a special receiving tray still needs to be done manually. This operation, depending on the laying speed, can be carried out by 1 to 4 people. The laying speed averages about 2 meters per minute. To adjust the direction of movement, Tigerstone is equipped with a special sensor that keeps it on the designated trajectory. The width of the paved road achieved in one pass of the machine ranges from 3 to 6 meters. The claimed productivity of the machine when operated by 2 workers is 300 square meters per day. Construction drones have been created to improve safety in high-altitude work. These unmanned aerial vehicles, operating in a coordinated mode, are designed to ensure maximum safety during construction work at height. Developers have designed a program through which a group of drones successfully constructed a 6-meter-tall tower with a complex design. Several hundred blocks were used for the construction, and the drones precisely placed them according to the 3D blueprints on their first attempt. The developers claim that modern drones already possess sufficient power to lift massive building blocks. These robots can significantly accelerate the construction process as they do not require breaks, weekends, or interruptions for nighttime rest. Considering their ability to coordinate their actions and follow the project plan accurately, it is foreseeable that drones will be used in real construction work in the near future. Swiss robots are already building 3-story houses. A team of engineers from the Swiss Federal Institute of Technology has developed what may be the world's first house that is nearly entirely constructed using digital technology, 3D printing, and robotics. The primary construction tool is a 2-meter robot on tracks. It creates large frameworks from closely spaced steel bars, which serve as formwork and reinforcement for concrete structures. It can create various shapes, including those with 2 curved contours. Inside the framework, a special concrete mixture is poured, which, thanks to its composition and closely spaced rods, does not spill outside. Another process called smart dynamic pouring is used for the facade of the first floor, specifically to create window mullions, vertical intermediate bars. The second and third floors of the building are constructed in the laboratory using assembly robots. The first skyscraper set to be 3D printed in Dubai is promised by Kaza Construction. To fulfill this order, they have invented 3D printing with the use of cranes, enabling the construction of buildings that are at least 80 meters tall. The TERMS project has been under development for many years with the aim of creating artificial termites capable of building complex structures or engaging in rescue operations. Another planned application area is the exploration of the surfaces of other planets. The research group from Harvard University is leading the development. The concept is based on the idea of scalable artificial intelligence capable of autonomously solving complex tasks. As of today, robots have already learned to build pyramids, towers, and other intricate structures. Write in the comments which of the building technologies presented today in this issue impressed you the most. If you enjoyed the video, don't forget to like it and subscribe to our channel. See you later.